Okay, so now we've done the third pendulum lab, right? This is the one where you're testing the variable, does the mass affect how many times it swings in a minute? And this is the one I think that is the most interesting of the bunch. This is where it gets to some very, strange and unexpected kind of results. And hopefully on yours, when you had it at a certain amount of mass, it swung a certain number of times in a minute. And when you had it at a larger amount of mass, it swung pretty much at exactly the same rate. Now, here's the thing. There's a real easy way to mess this up, or at least to not have accurate data. Remember, I told you that you got to measure the length of the string to the center of the mass. And if you have an odd shape, sometimes that's hard to estimate. But that is really crucial to get the length of the string because we've already determined in Pendulum Lab number 2 that the length of the string has a big impact. The longer string, the fewer swings you're going to have. So if you're going to try to isolate it to where you have two pendulums of different mass, they have to have the same length of the string in order for it to be a fair test, to be a controlled experiment. So if your data was off, that might be one of the reasons why. Having an odd shape can be kind of peculiar. But when we're in the classroom, we use lead weights and you can add mass to it and you could put them on the scale and say how much they weigh. You could quantify it. Now that's the thing we're missing doing it at home. Chances are at home you don't have an accurate scale that you could get within a gram. Okay, you might, but chances are you don't. So here's the data we had from 2 years ago when last time I taught eighth grade. And this is my 6 periods data. And I could have shown you any of my periods data. You end up with the same results. When you have swings per minute, this way, 10, 20, 30, 40, 50, up to 120 swings per minute. The mass of the bob going this way up to 200 grams, a little over 200 grams. Now look at this. What you have here, 20 grams and 200 grams, that's 10 times as much mass. And look, it's right even Steven with what you get at 10 grams. Okay? And so what you'd expect to see when you graph the data, if the mass had an effect, that you'd see a definite decline. It would drop off. Or actually, I'm doing it backwards for you because the mirror image. It would drop off as you go this way. Or it would rise up as you go that way. And so, but is that what happens? Does it rise up or does it drop off? No, it stays pretty much even. And in fact, you can have more and more mass as long as the length of the string stays constant. The swings per minute would stay constant as well. Now, this is it led to some dramatic discoveries with Galileo, and I'm going to get back to that. But before I do, let me show you a pretty dramatic demonstration of this that Walter Lewin, the MIT professor, when he teaches this same content, but at a graduate level, MIT, best science universities in the world, he gets to do a pretty cool demo. So here it is. Check this out. Does the mass affect the rate of swinging?
Is that the period of the oscillations is independent of the mass of the object. That would mean if I join the bob and I swing down with the bob, that you should get that same period. Or should you not? I'm asking you a question before we do this awful experiment. Would the period come out to be the same or not? Some of you think it's the same. Have you thought about it? That I'm a little bit taller than this object, and that therefore maybe effectively the length of the string has become a little less if I sit up like this. And if the length of the string is a little less, the period would be a little shorter. Yeah? Be prepared for that. On the other hand, I'm also I'm not quite prepared for it. I will try to hold my body as horizontal as I possibly can in order to be at the same level as the bob. I will start when I come to a halt here. There we go. No. You count. This hurts. Ah. I want to hear you loud. man T with Walter Lewin. 45.6 plus or minus 0.1 seconds. Physics works, I'm telling you. I'll see you Monday. Have a good weekend.
Well, I'd say that that's pretty conclusive. As long as you keep it with the same rate of the same length of string, and that's why he had to lie prone like this to keep the mass, the center of mass, to be the same distance from the point of attachment. Anyway, mass doesn't affect it, and that is a discovery Galileo made that led to, well, let me just say, it led to him becoming famous throughout Europe. He became like a science rock star with this discovery, not just with pendulums, but let's take it a little bit further. Back to the story of Galileo in the next video. Okay, see you then.